welcome back. Today we're going to be talking about electricity, specifically Ohm's law. We're going to talk about electrical potential energy. Now we've talked about different types of potential energy. We had chemical, we had gravitational. Today we're talking about electrical potential energy. Electrical potential energy is the ability to move an electric charge from one point to another. How are electrical potential energy and gravitational potential energy similar? Well, just as a ball would roll down a hill, and if you can imagine a ball at the top of a hill, we've got the hill, we've got this ball up here. Well, gravity is going to pull it down the hill. Well, why? Because there's this gravitational potential energy. Well, a negative charge will move away from another negative charge. So if I had a negative charge and it was stationary, meaning it's locked into place, let's say, then I had this other negative charge that I bring close to it, there's this repulsive force. It's going to push it away, and it's the same thing. It's the same type of potential energy. If we hold this here, it's got this electrical potential energy because it naturally wants to move away. Just like we can hold the ball here, but as soon as I let go of it, it's going to naturally want to move away. The electrical potential energy of an electric charge depends on its position in an electric field. So if you can see right here, this ball has a lot of electrical potential energy right now. We've got a positive charge, and the flow goes towards this negative charge over here. And I've got this smaller positive charge, positive meaning they're red right now in my diagrams. Because I'm holding it here, it's got potential energy because it naturally wants to move away from the other bigger positive charge. So there is lots of potential energy in this first example. All right, there is lots of potential energy here, or we might say high potential energy here. Whereas in this example down here, the ball's much farther away, so there's less potential energy. And specifically electrical potential energy, because we're talking about electricity, not gravity. The electric field goes from positive to negative. So whenever we talk about electric field, and we won't talk about it a lot, but if we do, I want you to understand that the electric field is assumed to go from a positive charge to a negative charge. Okay, voltage equals potential difference. Here's what I want you to understand is potential difference isn't really a term we use a whole lot anymore in everyday language, but it used to be something that used a whole lot, and that sticks in scientific fields. Potential difference means voltage. Just think of it as like a foreign word, but it is the same word that we don't really use anymore, but it means voltage. Potential difference is measured in volts. That's why we say it's voltage. The voltage difference in potential between 2 points in a circuit. Repulsive force. The electrical potential energy increases as the charge moves closer to each other. And we've already talked about this bottom part. The main things I want you to get from here, all right, potential difference is measured in volts. Voltage is potential difference. So these right there are the two main concepts from this page. Current. Let's talk about current. Electric current, the rate at which charges pass through a given point. Well, we must be talking about a conductor because the charges are moving. So we're talking about something that's conductive that allows current to flow through it. The units, it's called the ampere. Quite often we'll just simply say amp. All right, so the units are amps, more simply put. But current is the rate at which charges pass through a given point. And what really is happening with current is it's the flow of electrons. Because it's the electrons that can move in a conductor. We've got two different types of current. We have direct current, or commonly referred to as DC current, or DC. The charges always move one terminal to the other in the same direction. So in direct current, you're going to have this flow of electrons that never changes. Right? It's going to go in one direction. The The other one is called alternating current, or typically referred to as AC. The charges switch directions, always moving back and forth in both directions. Example is house current. Really what this means is the current's going to go this way, and then the current's going to go that way, and then the current's going to go this way, and then the current's going to go that way. It goes back and forth. All right, it goes back and forth. Alternating current's going to change direction. It's alternating. Resistance. Well, resistance is caused by internal friction, which slows the movement of charges. The opposition presented to the current by a material or device. Certain things have more resistance. The more resistance an object has, the less of a conductor. So if it has more resistance, then it is less of a conductor, because what we're talking about here is resisting the flow of electrons. It is resisting the flow of electrons. And that's what's happening here with resistance. Alright, Ohm's law. Here's our equation. Alright, we know that typically everything comes down to some type of equation. And Ohm's law is a special equation that relates current, resistance, and voltage. And that's what I've labeled here. Typically the hardest thing for students here is the I part, because they keep looking for C for current, and it takes them a while to realize that I is current. I stands for current, and it's measured in amps. Boy, if that's not confusing, because we start looking for A in the equation, we look for C in the equation, we can't find it. But when they talk about current, they're talking about I. Okay, here's our first example. The headlights of a typical car are powered by a 12-volt battery. What is resistance of the headlights if they draw 3 amps of current when turned on? Well, our equation, as we know, is V equals I times R. The voltage, the current, because that's A, and they want us to find R. Well, divide by 3. R turns out to be 4 ohms. Okay. So, what is the resistance is what they're asking. What is the resistance? The resistance is 4 ohms. A stun gun produces 1.7 milliamps. Well, that's giving us I right there. And I'm going to convert it because it's giving us milliamps. Well, milli is 3 spots to the right. So to convert this back into amps, I've got to go 1, 2, 3 spots back to the left. So if I go 1, 2, 3 spots back to the left, I get 0.0017 amps. So there's my amperage. 3.6 volts. What is the resistance of the circuitry? They're having us find resistance again. So I'm going to put 3.6.0017 and then find the resistance. The resistance is 2,117.6 ohms. Awesome. Awesome. Alright. Here's what I want you guys to find on your own. And then when you're done with finding that one on your own, I want you to go ahead and answer these 3 questions. Hey, it's been a joy today. I'll catch you guys as always